So to do the ANOVA test, just go to your data tab, data analysis. You scroll to ANOVA. This is a one-factor ANOVA. Why? Because we are dealing with one factor here, which is nationality. Okay? We are doing nationality. We are comparing based on nationalities. Okay, so the input range, I'm going to select the whole thing. We are comparing by columns. Okay, the samples are arranged column-wise, Nigerian, British, American, where our alpha is 0.05. Then the input range, so we want our result to be. Let's start it from here. I think that's all. Click on OK. We are grouping this data by columns. Click on OK. So, tell me straight. So ANOVA single factor is what we are looking at. The summary statistics. We have group count, sum, average, variance, Nigerian, British, Americans, count 16, 16, 16, sum, averages, variances. Then you have the ANOVA output here. Source of variation between groups. We have, so here, the main thing we are looking at here is the p-value, okay, which is based on the F statistics anyway. The p-value says what? 0.0001, which means generally there's statistically significant differences between these scores, these averages, right? Is it clear?
Yes, sir. That means we'll accept the null hypothesis, yeah?
We reject the null hypothesis. Means we reject the null hypothesis.
I thought it's when it's higher
What?
than 0.05.
Say?
I thought it's when the p-value is higher than 0.05. That's when we reject the null.
That one you reject or accept?
Reject.
You reject when it is low. By the way, what's the null hypothesis here?
It's 0.05, yeah?
What's the null hypothesis?
Is it not 0.05?
No, the null hypothesis. That is the p-value.
The
That's the
p-value, okay.
critical
0.
p.
Yeah,
That's the level of
0.0.
significance, yeah. Okay?
Okay,
Mm.
okay.
Okay? So that's what the null hypothesis says, that the means are equal, right?
Yes.
All the means are equal, all. But the alternative hypothesis says that not all means are equal. Okay? Not all means are equal. So all the means are not all means are equal. So at least some are different.
So if you just, without the ANOVA test, if you look at the sample, looking at the mean, all the means are different. They are not the same. So
Yeah.
it's alternative hypothesis, yeah? That is correct.
Yeah, but you cannot judge by what you are seeing here. You judge by this result.
Okay. In the t-test,
Yeah.
0.05 was the
With
value
alpha.
that
Yes.
we're using to compare. But
Yeah.
here, which value are we using to compare?
It's the same 0.05 compared with this p value. That
So if I
0.05 is the level of significance.
the level of frequency,
Physical
okay.
p, yes.
So
That's what I compare with. Okay.
if I look at this p value now given is way less than 0.05,
Yes.
and you said we should accept the null hypothesis.
We should reject the null hypothesis.
So
When p is low, you reject the null hypothesis.
okay, when it's low, you reject. When it's
Yeah.
high, you accept.
When it's high, you fail to reject. That's to say you don't reject the null hypothesis. You retain the null hypothesis. You get when it is high, you retain
Mm.
the null hypothesis. That's to say when it's greater than 0.5, you retain the.
Because I'm a bit confused because
Okay, what's your question? Okay.
when
Okay.
we got 0.16 in the
Mm,
previous sequence,
yes. What did
we
we do?
rejected we rejected the null hypothesis.
Let me see. In the two
That one sample, the
once.
one sample t-test we did.
Okay.
Yes, we got 0.16 and we rejected the null hypothesis.
Are you sure? It wasn't 0.16. So
It was higher than 0.05.
really?
Yes, it was higher. When we use 50-50, as you now said, if we get to arrow, that's when we will use it properly. That a set does not have.
Okay, let me try it. Let's try it.
Uh,
Let's quickly try it. But I think I've changed some of these figures. So, have I? Don't remember.
no, it's not this one you changed. It was you copied it to another place and
Oh,
you changed that one.
okay. So this
Yes.
one, yeah, it was 56. The average was 56. So uh, let's see.
I think it was data analytics tools we used that time.
We use, okay. This will give the same result.
Okay.
Don't worry. I actually use the.
Unequal, yes, two, yes. Uh,
Okay, so
yes.
what did you say we should do here?
So it was 0.16 that we got.
Yes.
So it was higher than 0.05,
Yes.
which is the level of significance.
No,
So
here you retain the null hypothesis.
okay, you don't reject it.
No. Okay, if we
Okay.
reject it, that was a mistake. You retain the null hypothesis in this
Oh,
case. Mm. retain the null hypothesis. Whichever way, you retain the null hypothesis. So when P is low, you reject the null hypothesis. When P is high, you retain the null hypothesis.
Okay.
Yeah. So that's it.
So when P is lower than 0.05,
Yeah,
you
reject
reject.
the null hypothesis.
When it's high, you fail to reject.
Yes, fail to reject or you retain the null hypothesis.
Okay. It's clear now, sir. Thanks.
Okay. Okay, so this what we just did now is what we call a one-factor analysis of variance, because we are dealing with one group, which is not one group, I mean one factor. Okay? The factor here is nationality. We are grouping based on one factor, nationality. Okay. So it's also possible we can also do multiple factor, and do two-factor analysis of variance, also called two-way analysis of variance. This one is a one-way analysis of variance. Okay, this one is one way. Okay, so we can do a two-way analysis of variance as well. So let's see. Let me get data for that. So let's see how the two-way analysis of variance works. Like in this case, you can see there are two factors here. We have the nationality and then we have the gender. Okay. So we want to see how nationality and nationality and gender affects the scores of students in mathematics. Okay, so that's what we are trying to see now. This is nationality. So we want to see if the average score is affected by these factors. What factors? Nationality, the gender. So that's our goal right now. Okay. These scores, do these scores depend on nationality, and are they influenced? Are these average mean scores, are they influenced by nationality and gender? So that's our goal. Okay. So this is a two-way ANOVA. What are the two factors we are talking about? Nationality and gender, isn't it? Hmm? These
Yes, sir.
are the male students, the nationalities and scores of the male students. These are the female students. When you are doing this, the number of male students and number of female must be the same. Okay. You ensure that the number of items, the size of this sample, the samples must be the same. Okay. The male sample for the male, in this case, you have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Female has to be 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is called this is one-way ANOVA with replication. What's the replication? Because you can see repetition here. Male, 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 female, 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 female. Okay. So let's see how we can do that. What's our objective? What did I say our objective is? Somebody wants to try?
check if yes.
If what?
We are talking about the gender and the nationality here. So we are comparing the two to see if there is anything.
What are we actually comparing? We are comparing the means here. The mean scores of the Nigerian students, British students, and the American students. You see, okay, based on the factors of male and female nationality, you want to see if these factors have something to do with these averages, okay? Are you getting it now? What we saw before was one-way ANOVA. In one-way ANOVA, we're trying to see if there's a statistically significant difference between the average scores of Nigerian students, that of British students, and that of American students. Okay, there's statistically significant difference between their mean scores. That was our objective. Okay, but this time, around, we are using multiple factors now. We are using 2 factors. Okay, instead of just talking of Nigerian, British, American, we are talking of Nigerian male student versus British male versus American male versus like that. Okay, combination of the 2 factors. How do those factors influence, have something to do with whether or not the mean of these samples are different? Okay, so let's go.
Okay, sir.
Go to data tab. Am I recording? No. Okay, yeah. So let's compute that now. So we just go to the data tab, click on data analysis. Which one do you think I should take out of these 2? Out of these 3? We have ANOVA single factor, ANOVA 2 factor with replication, ANOVA 2 factor without replication. I've already explained the type of ANOVA we are doing. Which one?
ANOVA with repetition.
So we are going to use this. That's right. 2 factor with replication. Okay. Then you come to your input range box here. You are going to select the entire data, which is all of this. Okay. You are going to select all of that. Then you click on rows.
I've already put a share. There's extra SD card.
You
No, I
So you put here, it's asking you for rows per sample. It's asking you how many rows you have in each category. The males, how many rows for male, how many rows for females, which is what? We got 8, right? We counted 8 just now. Is that right?
Yes, sir.
Then for the output
Yes,
range,
sir.
you click that, you click there, and then you choose where you want your results. And then you click on OK. You like the outputs. A lot of outputs, right? So now, this is ANOVA two-factor replication summary. You have the Nigerian, British, American total. You have the male. Okay. So this is giving you the summary for the male samples for the males. Give you summary for samples for the females. And give you summary for the combination of both. Okay. For the combination. So you can see the total, the sum is giving you 16, 16, 16, because 8 plus 8. Okay. Then the sum is giving you this plus this gives that. Averages, average of this and that gives that. Okay, so generally this is just the combination of both of them. Exactly. Okay, so now
Yes, sir.
let's go to the ANOVA proper. So here, of course, it gives you the source of variation, sample columns. This sample is like the rows. The sample is when you say sample, like all the males now, all the male data is one sample. All the female data is one sample. Okay. So for the sample, it tells you, for you to know, you see this degree of freedom is 1. Degree of freedom is total number minus 1. You have 2 samples, male and female. 2 minus 1 is 1. They have 3 columns, Nigerian, British, Americans. 3 minus 1 is 2. Okay. All right. So now, see where we have see where we focus on as usual. Here, you can see it's telling you that the sample, the p-value for the sample, that's like the rows now, the sample is 0.81. P-value for the columns is what? 0.00 something. For the interaction is 0.0009. Okay. What this is simply telling you is that the gender does not seem to have